Hello everyone, I hope you are doing well. So in this video, we are going to discuss this Geeks for Geeks problem of the day. And today's problem is intersection of two sorted linked lists, and it is an easy level problem. So the problem is fairly simple. So it basically says that we have to find the common elements between two sorted linked lists, right? So for example, if this is linked list 1 and linked list 2, what they are essentially saying is the common elements between these two linked lists is 2, 4 and 6. So as we can see, 2 is here in both of them, this is 2 and this is 2, then we have 4 and 4 in both of them, and this is 6 and 6 in both of them, right? So the elements are not necessarily distinct. That means there might be some repeating elements as well. For example, if I have 1 2 2 and 2 2 3, you see 2 is common 2 times in both of them. If I write one more 2 here, then it will still be taken 2 times because there is no third 2 here, right? So this is what we essentially have to do. We just have to figure out the common elements, and the problem is essentially very simple. The best part about this problem is the linked lists are already sorted, so that makes this problem very easy. You see that we have these elements like this, and there's one more thing, that the new linked list should be made without changing the original linked list. So that means we don't have to perform any algorithm in place. We can make a separate linked list. So what we essentially have to do is we have to maintain two pointers here, right? So we have each pointer in each of the linked lists, and this pointer will move forward. So now you must realize that if the element in the first linked list, let's say a1, is less than b1, then we will try to make this element equal to b1, right? And how can we do this? We can try to do the same by increasing the value of a1. So if by increasing a1 we can make it equal to b1, that means we have found some common elements. Similarly, if a1 is greater than b1, then we will try to increase b1, right? So that they can become equal. What if they both are equal? If a1 and b1 are equal, that means we have found some common element in both of them. We will take that particular element and increment both a1 and b1, right? Or a pointer or b pointer. So basically, initially these pointers were here. So you see that 1 is smaller than 2. So we will try to increment the first pointer. So we make this pointer as it is, we increment this particular pointer. Now you will see that both of the elements at both pointers are equal. So what we are going to do, we are going to take 2 as a number in our final linked list, in our result linked list, and increment both of the pointers. So the pointers will be like this now. Now again, the first element is smaller than the second element, so we are just going to increase it. This pointer has been incremented. Again, both of the elements are equal, so we take both of them, take this particular element in the final linked list and increment both of them. Now again, both of the pointers are same, so 6 is added. Now this pointer is incremented at both places. Since we have reached one of the null pointers, if we reach null pointer in any of the linked lists, that means we cannot find any further elements, and if there are no elements in one of the linked lists, then definitely there cannot be anything common. So this is exactly what we do here. We have this new head and current node, right? So basically new head is going to denote the head of the new linked list that we are trying to form, and current node is going to denote the current node in that particular new linked list. So while head 1 and head 2 is not equals to null pointers, that means there is at least one element remaining in both of the linked lists, then we will enter this particular loop. Now if the element or the data of the first linked list is smaller, then we are just going to increment the pointer of the first linked list. If the second data is smaller, then we are just going to increment the pointer of the second linked list. Now in case both of them are equal, that means we have to take that particular element in a final linked list, and that is why we have these two cases. So why are these cases different? Suppose we don't have a head right now, that means there are currently 0 elements in our linked list. So in that particular case, we will have to initialize a new head first, right? So what I'm doing is I'm just using this constructor of node. So there is a struct called node, and they have a default constructor, right? So I'm using this constructor to create a new node, that is new head will be equals to new node of head.data, right? So I'm just passing the data into it. Now I also have to initialize my current node with the new head. So current node will obviously denote the last used node, right? And in case the head already exists, then what I'll do, I'll set my current node next as the new node. So for example, if there was no head, if there was null pointer initially in place of head, so I'm just going to put a new node there. Now if there is already a node, I'm just going to put the new node in the next of this particular node, right? So current node next is equals to new node, and the current node will get updated by current node next. So my current node will become this one now. So this is how you can solve this problem, and obviously the problem was easy. I hope that you guys were able to understand the solution, and if you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that was it for today. I'll also be trying to upload the lead code problem of the day as well, so stay tuned for that in case you are interested, and definitely do comment your thoughts in this video just for the YouTube algorithm. And that's it for today. Till the next video drops, keep coding, stay safe, bye bye.